Alright everyone, moving on to the advanced TypeScript features section. In this section, we are diving into some of TypeScript's advanced features that will make your code more powerful, reusable, and type safe. We'll start by talking about literal types, which is a powerful feature TypeScript offers for restricting values to specific fixed types. Then we'll move on to more advanced topics like type guards, type assertions, keyof, and indexed access types, and conditional types. These concepts will help you ensure your code behaves exactly how you intend it to. So let's begin with literal types. In TypeScript, a literal type allows you to specify a specific value for a variable rather than a broad type like string or number. Literal types are useful when you want to limit a variable to a small set of predefined values. For instance, imagine you are working on a function where you need to restrict the possible input to a set of values like red, blue, or green. Instead of just using string, you can define it as a string literal type to enforce that only those values are allowed. So let's go to the example. In this case, the color variable is restricted to only three valid strings, red, blue, and green. If you try to assign yellow, TypeScript will give an error because that's not part of the allowed literal set. This ensures data integrity by preventing invalid values from being assigned to variables or passed as function arguments. Literal types are not just restricted to strings, they can work with numbers as well. So let me give you a quick example. In this example, the variable dice roll can only have one of the values 1, 2, 3, 4, 5, or 6. Any other number like 7, 15, etc. will result in an error. Numeric literal types are particularly useful when you are dealing with a set of possible numbers like dice rolls, ratings, or age categories. They make your code more predictable and safe. We'll now move on to type cards and explore how you can narrow down types dynamically to enhance the flexibility of your TypeScript code. Right, so in TypeScript, type cards are techniques that help you narrow down the type of a variable within a specific block of code. They allow you to perform checks and tell TypeScript the exact type of a variable, ensuring type safety. Let's start with two commonly used built-in type cards, typeof and instanceof. These are used to check the types of variables during runtime. For example, if you want to check whether a value is a string or a number, you can use typeof. Here's the example. In this code, we use typeof to check if the value is a string or a number. If it's a string, we return its length directly. If it's a number, we convert it to a string and then get its length. Similarly, we use instanceof to check if an object is an instance of a specific class. Here's an example. In this example, we use instanceof to check if the parameter person is an instance of the person class. If it is, we access the name property, otherwise we treat it as a string. Now let's talk about custom type cards. Sometimes you might need to create your own type cards. These are functions that return a Boolean value and help narrow down types in a more specific manner. For example, let's say we want to check if an object is a person type. We can write a custom type card like this. Here is person is a custom type card. The return type value is person tells TypeScript that if is person returns true, the value is definitely of type person. Let's see how we can use this custom value type card in a function. In this example, the isPerson function narrows down the type of person so we can safely access the name property if it's a person. And you can check that if I click over here and press dot, you can say it's giving me the name property just like it would if it knew that the person is of type person with a capital P, not any. If any of this didn't make sense, let me know in the comments and I'll try to explain further. A related concept to value is person, which results in a type being determined, is type assertions, which is our next topic. So type assertions are a way of telling the compiler, trust me, I know the type of this variable better than you do. It's useful when you are certain about the type of a value, but TypeScript isn't able to infer it automatically. So there are two ways to perform type assertions in TypeScript. Let's take a look at both. In this example, some value is of type unknown, which means we don't know the exact type. However, we assert that this is a string using as string and then access its length property. Alternatively, you can use the type syntax in angle brackets, which looks like this. This syntax works in the same way as string, but it's a little more common in JavaScript projects. Both methods achieve the same result. The important point is that type assertions do not change the runtime behavior of the code. They just tell TypeScript to treat the value as a specific type. Now let's dive into Keyof and indexed access types in TypeScript. These are powerful features that help you work with object types and their properties more effectively. So first, let's talk about the Keyof operator. The Keyof operator takes an object type and produces a union of its keys. This is helpful when you need to refer to the keys of an object type. For example, let's say we have an interface representing a person. We can use the Keyof operator to get the keys of the person interface as a type. In this particular case, person keys will be a union of the string literal types name, age, and address, which are the keys of the person interface. Let's see a practical example of how this can be useful. If we want to create a function that accepts a key from the person object, we can use keyof. Here the function getValue takes a person object and a key of the type keyOfPerson. The key can only be one of the keys from the person interface, ensuring type safety. Here we go. We were able to access the address of the person using the address being passed as a keyof. Next, we are going to explore indexed access types. Indexed access types allow you to look up a specific type in an object or array based on a key. This is done using square brackets and the key you want to access. Let's take the same person interface. If we want to access the type of a specific property dynamically, we can use indexed access like this. In this example, person square bracket name gives us the type of the name property, which is string. Indexed access types can be useful when you want to dynamically extract types from objects or arrays based on keys. Right, now let's explore conditional types in TypeScript. So conditional types allow you to express logic about types, where the type changes based on a condition. Think of them as if-else statement for types. Let's start with basic conditional types. A basic conditional type has the following syntax. And this reads as if type T extends type U, then the type is X, otherwise the type is Y. It won't make sense without an example, so let's write an example to make it clear. Suppose we want to create a function that checks if a value is string, and based on that we return either a string or a number. Here's how we can use a conditional type for that. Here isString is a type that gives us yes if the input type is a string and no otherwise. This is super useful for creating type helpers or building logic into your types without writing any JavaScript at all. That finally brings us to the end of advanced TypeScript topics. In the next section, we are going to look at some practical TypeScript topics, so stay tuned.